So in the last video, we have seen, even though we wrote the correct code in the functionality wise, that means when the user sees, he cannot see the switch off scenario during the next iteration. That means he cannot see the second iteration or third iteration because he didn't switch the LEDs off in between each for loop iterations. Okay, that means we are repeating the switch on again and again to an LED that is already on. Pointless. Okay, so what I will do is, once this during each and every iteration of this white loop, once all the for loop are done, that means we switch on all the LEDs. Let's say during the first iteration of this white loop, for loop happens, so we switch on all the LEDs. We switch on all the LEDs. Once that is done, we will switch off all of them. Okay, immediately, without any delay, we switch off. That means fifth LED is on and there is a delay before the for loop and the for loop ends. Okay, and then before it is going to the next iteration of the white loop, and again switch on the already switched on LEDs before that. Okay, after this first for loop breaking, before the next iteration of the white loop starts, we will immediately switch off all the LEDs. Okay, so let's see how we can switch off the LEDs. You know the code. Okay, okay, so just see this. Okay, in that particular iteration we have already said, like when we come out of the for loop, we have already said all these 5 pins are output. That will never change. We never change it anywhere else after that. Okay, all these 5 pins become high. That means once we come out to the pin number 15, these two are done, and there's a delay also happened after the 5th LED switched on. Then we come to the line number 15. That means the for loop is broken because 5 LEDs have passed. All the LED values are now output set to output. All the digital write are high, and the 400 millisecond of a delay also happened after the last iteration of the for loop. Then we broke the for loop because I became 8. You get it? And we came to line number 15. Then I immediately am going to switch off all the LEDs. 3, 4, 5, 6 and 7. Okay, and I'll make it low. Okay, switch off means low. So since there is no delay between each and every line, all these things will happen at the same time. I already explained you this in one of the initial videos. If there is no manual delays given in between two lines, the program moving from one line to other line is, we can consider it in 0 time. Okay, 16 to 17 will happen in 0 time, almost no time. So we can think all these line things will happen at same time. That means all the LEDs should go off at the same time. There is a plan, right? We switch on each and everything in 400 millisecond delay, and we switch off everything at the same moment. So we have done it. Now if you are smart enough, you will come and say me, okay, you have switched on every LED one by one and you are done with it. But when you are switching off, again there is a possibility you can refactor the code and you can put this into a for loop. Why do you have to write all these 5 lines? Okay, the same 3 to 7 things are happening here also. See, 3 to 7, but you have to do it after the last LED switched on. You have to switch off everything together. Okay, why don't you write another for loop and switch off everything together with one line? Why are you writing it repetitively? That's very correct, right? So what I will do is I will again write a for loop sorry guys, and I will initiate the I value as 3 because I again want this I 3 to 7. I don't need to redeclare the value because I have already declared the I, so no problem. So last the I value will be 8 when we are coming up to the line, because I is 8 means what is the thing? I is 8 mean what? This is false. Okay, sorry guys, this condition is false. That is why I came out of this for loop and came to the line number 15. Now I reassign the I value to 3 again, and I ask the I to go up to 7 because I want to switch off the LEDs from 3 to 7, but without a delay, because at the same time it should happen. Okay, see these guys. Okay, and I open and close and for loop. Okay, then what I will do is I will have a I here. Okay, so now at the first iteration of the for loop, again you can break it to this workflow. Okay, you start from here, come here and iterate within this blue colored highlighted area. When it become 8, it will break up. Okay, iterate within this. It will never go to the I is 3 once it passed the line. Only one time it will go. Then it will iterate within this, and once the I become 8, it will break. You know this, okay? Because it's a new for loop. Okay. Okay, that's cool, right? You understand that. So we will remove all this unnecessary code, and now look at the code flow. Initially I value is 3 and I ends in 7. The same thing. Okay, but we do it together at all. We cannot have this switch off scenario here inside this for loop, because if we switch off inside this for loop, what will happen? We switch on an LED and then switch off the same LED. We don't want that. We switch on all the LEDs one by one. Only after the fifth LED also on, then we have to switch off everything together. So that is why we need 2 for loops. Okay, so that is understandable by you, I hope. I don't want to explain that also. So now look at this for loop. From I is equal to 3 to 7, we will get into this. 7 also included because we have an equal sign also here. Okay, so 3, 4, 5, 6, 7, we switch off all the LEDs together. Then when I become 8, this for loop become false, because this will become false, and we will break the for loop, and we will come to line number 19 and 20, and void loop will restart. Again int I is equal to 3 to 7. Now all the LEDs are switched off because we have done it here. Now again we switch on, we we say this LED is output, and we switch on this. Okay, you get it? First LED will be switched off, on second LED switch on, third, fourth, fifth, one by one with a delay. Okay, then in the for loop all together all the LEDs will be switched off. Why all the LEDs will be switched off? Because there is no delay. So from one line to another line, the running of the program will be very fast. That means the iteration of the for loop is almost will happen in no time, all the 5 iterations, because there is no delay. Okay, you get it? Because I say it, if there is no delay, manual delay is given from one line to another line, movement will happen in almost no time. Okay, so now see this pin mode thing. Okay, one more thing. So if the digital write high is fine, we have to redo again and again, and we have to do the switching off also. But this pin mode I output thing, okay, saying this pin mode is output, if you do it one time for all the 5 pins, that's enough. We don't have to repeat it. So we can refactor this as well, because when the void loop is starting, we say this pin is output, 3, 4, 5, 6, 7 is output. Okay, then we never say anywhere else please remove the output from the pin. No, it's set is set always. So if we do it only one time, that's enough, because we do the pin mode thing always one time inside the void setup. Okay, now what happens is, if the void loop is repeating, we again say this is unnecessary. Switching on again and again is needed, switching off again and again is needed, but saying pin mode is output repetitively is not needed. If we do it 5 times for all the 5 pins one by one, okay, altogether 5 times of pin mode is enough for us. So during one void loop iteration, all the 5 times output saying will happen inside one for loop. Okay, then we don't need this. Yes or no? Yes. But so what we can do is, we can bring this part to void setup loop. Okay, void, because we will do it only one time. So we will do that refactor in the next video, and we will have a look at the demo in the next video, guys. So just follow me in the next video.